Shared objects are useful when you want to share a couple of functions between different programs. They're used a lot on Linux. For example, if you run LDD on bin bash, LDD, by the way, shows you the shared objects that a program uses. You can see that bash depends on a couple of shared objects. By the way, this shows you the link time shared objects. That means that these were specified when bash was linked. There's also another way to load shared objects, and that's dynamic. And today we're going to look at both ways. Let's start by writing the code of the shared object. I'm going to open share.c here. It's just going to print something on the screen, hello. I'm just going to export a single function. Let's call it hello. It's going to print hello. Now I'm going to save this. And I'm going to start by the first and most popular way of using a shared object, and that is specifying it at link time. And for that, I'm going to open another program. Let's call it loader, for example, loader.c. All you got to do is just, first of all, declare that hello exists somewhere. And then I'm going to make my main function, which we'll call hello. That's all for the code here. I'm going to save this. And I'm going to start by compiling the shared object. I'm going to run gcc with the -shared flag and pass in the shared object. You can see everything is successful. If I run ls, we see the a.out here. Now all I gotta do is just move a.out. And I'm gonna move this into user lib, which is one of the directories that are searched when you specify shared objects. And I'm gonna give it a name according to what GCC searches for when you specify a library. That's gonna be starting with lib, and then whatever you want. Let's call it hello shared.so. Also, I'm going to run this with sudo, since we're talking about directory that requires privileges. Now the shared object is ready. All I got to do is just compile the loader. And I'm going to specify with -l the name of my shared object, and that's without the lib, so just hello shared. Now I got a.out here. All I got to do is just run it. And you can see it works nicely. It calls the shared object. By the way, if I run LDD on a.out, you can see that indeed one of the dependencies is the shared object we just created, lib hello shared. Now I'm going to show you the second method. That is less popular, but it's also cool to know about it because sometimes it can be useful. I'm going to open the code of the loader. And let's open the man page for dlopen. dlopen enables me to open a shared object. But the difference with the first method that we did before is that this lets me do it while my code is running. The first method loads the library when the program starts. Let's add this include file. Instead of hello, I'm going to call dlopen here. For the file name argument, I'm going to pass in the name of the shared object. I don't need to pass the full path for the user lib because, as you can see here in the man page, directories lib and user lib are searched. Second argument is going to be the flags. Let's see what we need to pass in there. We can see that we can specify lazy loading or just load everything when it's called. I'm just going to load everything because we don't have a large shared object. It's just a single function. I'm going to specify this option. Now if we go down to the return value, we can see that it returns a non-null handle in case everything is successful. I'm just going to assume success. This is not production code, just for fun. Afterwards, I'm going to call dlsim. This lets me obtain an address of a symbol from a shared object. Here I can actually get the hello function from the shared object. First argument is going to be the handle. Second argument is going to be the symbol that I want to use. In this case, it's going to be the hello function. And this will return the address of the symbol. So I'll get back the address of the function. Afterwards, I need to treat this as a function pointer. So I'm going to save this into a function pointer variable. Yeah, function pointers are kind of confusing a little bit, but here's basically the name of the variable. Let's maybe give it a more indicative name. Now, assuming everything is successful, I'm just going to call this afterwards, and we should also see hello on the screen. Just fixing the shared object name, it's lib hello shared. Let's go ahead and compile this. I'm gonna run GCC, compile and link this. Now if you go ahead and run a.out, we can see that works nicely. If you want to see a little bit how it actually works, we can just run ltrace. And we'll see exactly the two calls that are happening. First one is dlopen on our shared object, which will return the handle. And then it's going to call dlsim with the symbol that I want to use, in this case hello. And finally, hello actually happens because I call the function. Subscribe for more programming videos, and thanks for watching.